So we have a material test that's located on our website. If you haven't used it before, it's really useful. It looks kind of as you see down below. And what we're basically going to do right here is we're going to run you through the material test in real time, exactly how you use it. Some people have wondered, okay, well, I have this little 1 inch by 1 inch square. How do I actually use this material test? Well, here we go. We'll walk you through it step by step. Now, basically, the first thing you want to do, and we'll pull up the software here, the screenshot. Oh, excuse me. Okay, so you go to our website here. Now, the web address up there is basically laser101.fslaser.com/material test. If you just go to our Laser 101 homepage, you'll see it on the bottom. Can't miss it. So once you get to the page there, you go down to the download files, and what you'll see is 5 files there. The one all the way to the left is the material test file that you need to have. That's what you'll download. The other ones are an AI file if you wanted to download it and have it in Illustrator. The PDF, though, is editable, though, inside of Inkscape if you wanted to open it up in there. There's also 2 material test log sheets that are right there. One of them is printable, and the other one you can actually download and use inside of Excel if you wanted to keep track of it on your computer. And then the other file is just a zip file that has all of those things contained in one if you wanted to just download one all at once. So once you have it downloaded, you just want to drag and drop that into your Retina Engrave software. Now, as you can see, we have it drug in here, right here. We have a piece of Kona wood inside the Muse Hobby Laser here that is actually a piece of wood that the Fender research and development team uses as they are developing new guitars. Fender actually just picked up one of our Pro 36 machines as well as one of our fiber lasers for the research and development team as they develop new guitars. So this Kona wood that we're going to do a material test right here, we're just going to put that 1 inch by 1 inch square up towards the top. And as you can see, it has a solid fill in the middle and then 6 different vector color lines. Now what we're going to do is basically run this test 3 different times because this one square allows you to run a material test 3 different ways. So the first way we're going to do it is as a solid fill engraving. Now, what we're going to first do is just on the material test side, we're going to, on RE2, hit the eyeball sign for the vectorization so that we don't run the vectors on this job. So we're just going to hide the vector line. There we go. Sorry about that. Now, the engrave section here, we can have 2 sections. Now, if on the engrave section, if we hit halftone dither, what we can do is you'll see that middle section is actually, we hit halftone dither, please. Thank you, sir.
It's halftone.
Is it dithered out?
Yep.
Oh, there we go. Oh, I'm sorry, I was looking at the wrong monitor. So with the halftone dither there, you can see that it actually is a perfect gradient from black in the middle to white all the way on the edge. There's an example of it there in the bottom left-hand corner of the screen. Now, that's at 250 DPI. You see there, that gradient dot pattern will actually change and be less noticeable as your DPI goes up. It's just more noticeable there, so you could see in this example. Now, we're going to go back to a solid fill, though, in RE2, which all you have to do is click the button right above it, and it takes it back to a solid fill. Now, if you go over to the black and white threshold, basically, as you slide the black and white threshold left and right, you'll see more and less of that circle appear. So basically what we're going to do is just adjust that circle so it is encompassing all the way outside of that last circle, but not quite making it, there you go. So it's just one complete circle. So now our power and speed settings at 250 DPI, we're just going to go with basically 50% power and 50% speed. Okay, so then once we have that set, if we want, we can swing over to the camera in the Muse, and we'll see we have it lined up right there in the middle. This on our 40-watt unit there. We're just going to run the perimeter real quick to double check our location, and then we'll just run this perimeter real quick and kind of see what we have. So with the material test, it's important to keep track of the settings that you used as the job is running. This is basically going to give you a basis to go from once you have a look at how the test has come out. So as you can see, it just being a 1" by 1" square, you can actually make this bigger or smaller in RE2 or RE3 just by clicking the corner and dragging it larger and smaller. We have it arbitrarily at a 1" square, just so it's easy to plan for. Now, as you can see, at 50% power and 50% speed, the engraving is pretty good. It's a pretty good mark there. Pretty deep. The Kona wood isn't super hard, but it is rather dense, even though it's a bit soft. If you've never worked with Kona wood before, it's a great wood for not only engraving, but also for cutting and marking. It just cuts super clean, fits together well. Now, Ruben, if you would just kind of tilt the wood up a little bit closer to the camera, as you might want to push the laser head a little bit out of the way before you do. But we'll just tilt that up near the camera that's inside the muse so that we can get a good look at the wood. You might have to take it out from underneath the, there you go. Now, as you can see, that's a pretty good mark. I don't want to say there's anything to complain about, but a nice clean mark. Yeah, there you go, Ruben, that's good. It looks about 1.5 millimeters, maybe 2 millimeters deep. Real nice. So if you would put that right back in, Ruben. Now, let's say the goal here was, though, you want to have a nice, deep, dark engraving. Now, how would we make this engraving darker, Walker?
More power.
More power. So, what we're going to do is we're going to put the laser back over top, and then Ruben's actually going to initiate the camera sequence right there from the Muse Hobby Laser. If you don't do this yourself, it's really easy to initiate the camera sequence by pressing the camera button once on the Muse, and then pressing it just a second time once it turns white, and that'll start the camera sequence. This is great because it'll run the camera sequence in the background, and you can continue using RE2 or RE3 while the camera is doing its work on the Muse. So once we have a good picture of the laser bed again, we're just going to position the material test a little bit below that. If you want to bring the camera back over to the software, Charles, thank you, sir. Now we're just going to take that material test and we're going to move it down a little bit below and run it one more time really quickly at a different power and speed settings, and just show sort of a difference on what you can do. Now, obviously at 50 power, 50 speed, that can get a little bit darker. Now, if we increase the power and keep the speed the same, it will basically it should make it darker than that with a very similar output as far as time is concerned.
So we're going to put it power what?
I'm just going to, so we'll keep the power, we'll move the power to 100, and then we'll keep the power or the speed at 50.
Alrighty.
Kristen Sandbauer Bodmer, thanks for tuning in and watching. Do we have any other viewers that we can give a shout out to?
Jason. Jason was watching, yeah?
Hey, Jason, how's it going, sir? We do have a quick question from Alec in Fresno, it looks like. Sorry for missing that, Alec. It says, help, my Muse camera isn't working. All I get is a black screen. Luckily for you, sir, that is an easy fix. Chances are it's just your lens cap is on your camera. Don't worry, happens to the best of us, happens to me. Just check the lens cap on the camera. Chances are you just got to pull that off. It's a good thing to replace on the Muse at all times. That way, as you're running, as you can see, there's a lot of smoke and debris that comes off of an engraving as you're running your Muse. So it's always a good thing just to keep the camera cap on anyway. But if you're getting black screens when running the camera sequence, chances are it's just that. One more. Jake in San Diego asks, will we be at Maker Faire Bay Area in May? We absolutely will be at Bay Area Maker Faire in May. Come check us out in our normal location. We'll give you more details on that in the next couple weeks as it comes up, but we'll absolutely be there. Dremel will actually be there as well, revealing their version of the Muse, the Dremel Digilab laser cutter. That'll be its first full in the public demo. They released it last year at World Maker Faire, and this will be the first public display. Well, they'll be doing demos as well. So come check out the Muse. We'll have RE3 on Pro demos on software display there to check out as well. So Maker Faire in San Diego, in Bay Area, definitely worth checking out this year. All right, Ruben, thanks so much for manning at the Muse there again. Now, as you can see, very plainly, even from this distance, you can see it's much, much deeper than the one above. So with this material test, that's really the ideal way to run it. You give one test, kind of see where it ends up, and then see what you get with the second one. Now, you'll see some lines in there, and that's really just from the grain of the wood. If we twisted the wood a different way, you would still see the lines in the wood that same direction, as it's just the grain. And as the wood grows, that's actually, you're seeing the growth pattern there. Each year as it grows, there's a section of the wood that grows, it's a little bit more dense. That's the dark part of the edge there, and then the lighter section is the kind of the growth spurt that happens during the growing part of the season.
And it's important to notice that this is a solid piece of wood.
Absolutely, this isn't a ply.
Yeah, so you're going to see those grains a lot more.
Absolutely. So if we would now, Ruben, if you'll switch that piece of wood with the birch that we have right here, Walker, I'll hand it up. This is actually, yeah, go the other side up. Yeah, that side down. There you go. Yeah, that up. Yep. So this is a pretty standard birch veneer. This is a little bit nicer quality than you would get at the standard store. This is on par with a Romark quality of materials, which, remember, if you are a FSL customer, hop on to Johnson Plastics Plus and pick up some Romark materials. They just sent us a Christmas load of materials to make some projects on. We got it in today. Big shout out to Romark and Johnson Plastics Plus. Every Muse and Hobby Series gets a maker pack with it. Use that 10% off discount. It goes a long way. The prices on their products are essentially the exact same as they are if you went to Joann's, or where else would you go? Michael's or something like that. You're paying about $5 a sheet for a 1 by 2 foot sheet of material, but they also have the larger sheets. So if you're a pro user, man, I'll tell you, we just got a bunch of, what are those, 2 foot by 4 foot sheets?
They're huge.
They're huge. They're so big. They're bigger than the table we're sitting at, and they are amazing on the Pro 36 and 48. Even if you have a Pro 24, they fit through the pass-through doors. It's just to us, it's the only way to get materials by big sheets.
Yeah,
it's way better. Okay, so now that we got the other piece of material in there, we're just going to show you the dither function and sort of how to dial that in. And when you're doing a dither, chances are you're going to be doing it with a photo, or you're going to be doing it to show contrast in some other sort of design. So what we're going to attempt to do here with this dither is just give a nice even marking on the dither as to show a full scale gradient across. Now, the third way you can use this we'll show you next, and that's just to use the vector marking, so you can kind of figure out which vector power and speed settings you can use for either vector marking or vector cutting on your material. So rather than running your job 4 times to figure out what's the proper speed and settings, you can start with our suggested settings and then use the other lines to kind of dial in from there what your speed and settings should be at. So as you can see, the object there is, we just positioned it over top of the birch in the software. Now we're going to hit the halftone dither button again, and you'll see that's going to take the solid circle back to the gradient. And again, that's a perfect gradient created in a design software where the center portion is a 255 black and the outer corners are a 000 white. So a perfect gradient from center to edge. This will allow you to sort of see the dynamic contrast across the board. Now, what you'll notice is some of those lines that go across the vector lines you can see, and some of them you can't. Now, the only one you shouldn't be able to see very well is the yellow one. The other blues, cyans, pinks, and blues will pick up with the dither because those fall into the grayscale when you hit the dither mark. So a good way to tell which, the reason those colored lines are used on the material test is so that you can tell what vector lines are going to be picked up when you do a halftone dither on your project. So now that we have that set, we're going to go ahead and go over to the settings. Now there's 3 settings on dither that you also want to keep in mind that are not just power and speed. If you could click on the layer there, and that is down below, which is the blur filter radius, the edge enhance threshold, and the intensity correction. Now real quick, just to run through those to show you what they do. The blur filter radius is essentially going to help the software figure out how much of the blur that's naturally put into autofocus things, how big the radius of those pixels are going to be. So if you push that slider all the way to the right, you're going to have a lot larger pixels in your blurred areas. This is good for stylized things, but typically you want to keep that setting right where it's at. Now the edge enhance threshold is one that you may use much more, and that basically, it picks up the edges. So if you can see along the edge of my shoulder, it would notice that edge of my arm and the background behind it, and it would give a little bit of enhancement on that line. So if you maybe have a group shot or some things that are a little muddy, play around with the edge enhancement threshold to have a few things come out that might not otherwise do so. And then the bottom one is the intensity correction, which basically is for lack of better terms, a brightness control. That intensity basically just helps with a little bit of the luminance of the image. And if something's coming out a little bit dark when you're engraving it, try giving it just a little bit of a nudge on the intensity correction and seeing if that helps. Same thing if it's coming out a little bit light. Same thing with the intensity correction. Just bring that down a little bit. Now, as you can see there as well, the material test also has those vectors. We'll do that on the next run though. So we're going to run this material test with raster and power speeds of 50 and 50 again at 250 dpi. Now, in this case, we're probably going to go with a lower power. You can go ahead and run the job. Appreciate you, Walker. So we're going to get this job running, but what we're going to notice as this job runs is we're going to actually probably dial back the power on this one as to just give enough of an engraving to show a real nice gradient. Now, when you're doing photo engravings, that's really what you're trying to do. You don't want to overpower a photo engraving. You don't want to give too much speed. You certainly don't want too much power, and you certainly don't want anything to be too densely located with pixels. So if you have a very busy photo, we don't really suggest you ever use 1000 dpi for photo engravings, but a very busy photo, you almost want to do a lower DPI on just so you can pick up a little bit more of what's going on. When engraving on tile, you almost always want to use a lower DPI as you're, you don't get a lot of difference as you're going across tile. What's another example of using a lower DPI is better?
I would say solid wood is a good one.
Absolutely.
It'll give you a better contrast.
Yeah. With the 250 DPI, there's almost a suggestion that it's a bit like a cartoony. Almost gives it a little bit of a, and that's actually kind of the science behind it, where the dot density is a lot like, newspaper density. So Ruben, if you want to pull that out and just kind of twist it around, so you can probably hold it in there upside down if you wanted. It's a little bright. Here, why don't you hand it to me? We can probably get a little bit better exposure on this camera. It's probably just a little bright. Let's put us on the big screen real quick, Charles. So as you can see, there we go. That was a pretty good engraving, but that was actually just a little dark. We don't have a real good contrast in the gradient. So what we're going to do is we're going to stick that back in there.
You can definitely see the difference, though, between solid and...
Oh, absolutely. There's no question the difference. But now on this run, we're basically just going to run this job with a little bit less power and keep the speed up. So we're going to take the raster speed and take it to 75 and take the raster power down to 25. Now, by speeding up the laser head and by giving it less power, we're not only allowing the laser to affect the material less because it has less power, but it's also affecting the material less because it's spending less time in any one position. So as you increase speed, you decrease the effectiveness of the laser as far as power is concerned. So it's still effectively to use, it's still as accurate, but if you were trying to maximize or trying to, I would say, get the most efficiency from it, you have to remember that laser head speed is essential as you're going through and dialing it in. Tiffany Brown comes in on Facebook and asks, I've been using 1/8 laser grade birch ply ever since I received my Muse a few months ago. All of a sudden, I'm not getting a clean cuts all the way through. Is there something I can do to improve this? Tiffany, great question. I appreciate you asking. So there's a couple things you can check. The first thing I would check is my alignment. That would be the very first thing, but even before I align the laser, I would probably clean my optics.
Yeah, I would definitely check the optics and make sure that there's no hazing or anything of that sort. Clean it with your lens wipe, and then if that still continues, then go ahead and walk through alignment.
Absolutely. Many times at home, I'll notice that the last few items don't cut out on a run, and I'll wonder why. The power settings worked for the last 4 hours. Why is it off now? Mm-hmm. And really, it's just because a little buildup has come up on the lens, and the laser beam just wasn't passing through the lens very well. You give every mirror and the lens a quick wipe, and you're back to good to go. It could be as simple as that. It could require just a quick alignment, though, which really, if you're already close, it's 5 or 10 minutes. It's not like you're aligning a laser from inception or like aligning some of our old pro lasers.
Yeah, And I mean, you got to think that anything on those lenses and mirrors is going to diffuse the laser a little bit, so it's going to throw it off just a bit. So anything on there, just clean it off.
Absolutely. But great question, Tiffany. We appreciate you you writing in with that. There's also a video which Ruben's going to grab the alignment video for you, and he's going to put that link down below in the comment on Facebook, on YouTube. Just check out our page, and it'll be probably one of the suggested videos at the end of this clip. So back to the software over in the thing. Now that we have that lighter thing, we've increased the speed to 75, we've decreased the power to 25. We're going to give this a second run. We probably should have done that as we were discussing cleaning optics. Sorry. Next time. We still are going to do one more run with the vector, so we can learn how to dial in the vector as well. Looks like Mike on Facebook has a Facebook. I got a little bit of an accent. Sorry about that. Mike on Facebook asks, I've been looking for at purchasing an FS Laser soon. Okay, Mike, if you're looking at purchasing a laser soon, please call us right now. We'll help you out with that right away. He's got a question though about training and learning to use the machine. Is there any training involved? I'm a little apprehensive in buying without any sort of training. What's available? Great question, Mike. That almost feels like it's set up for us, but we have Laser 101, which is a great learning section. It has this material test on it, which shows you how to dial in power settings for your machine. We have how-to guides, setup guides, quick startup guides, software guides, alignment guides. So many assets, different videos, design files. Walker puts out a new design file every single week, so you can learn how to design different things, like take his example and like build on it. Or
I think the projects are not only like a project, but they're good learning tools.
Absolutely.
On why things are made that certain way.
All right, Ruben, so let's take a look at what we got there. It looks like we got a nice marking. What do you think, Ruben?
Yeah, I definitely think so. I'm going to pass it off to you.
Yeah, absolutely. Thanks. Yeah, that looks great. So if I was doing a photograph, I would definitely be looking for example 2 rather than example 1. Here's why. The top one looks darker. It is darker. It absolutely is. But really the only thing that I want dark is the middle, because that's the only thing that's black. I want a nice gradient to go out to the edge. And if we're being honest, I would probably find something just in between here. Maybe just a notch up. Maybe I would slow the laser head down 10 or 15% just to get a little bit more difference in between the middle and the edge. But that gradient that goes from the center to the edge is really nice on that lower example there. Ruben, would you mind sticking that back in the laser, sir?
Yep.
Appreciate you, man. All right, so now we're going to talk about the vector lines. And this is the easiest one. It's really quick, and it's probably the most useful as you're doing cuts. So as we go over, we just hid essentially the bitmap data, and now we're looking at the vector data. As you can see, there is a yellow line, purple line, red line, blue line, what have you. Now, over to the right side, as you click on that object, you'll see all those colors off to the right. Now, what you can do is you can type in different quantities for those colors to see what cuts through. Now, it'll run in the order that you have listed there. So let's, in the red one, make our best guess as to what's going to cut. I'm going to say 35 speed, 100 power will cut through that birch. What do you say?
I think that's a good guess, yeah.
So we'll guess 35. So the line above that is that green. What do you say about that? Let's do one that's just a little bit slower, just in case. Let's do one that's at 30 speed.
All right.
And then with the what's the one right below it?
Orange.
So with that, the blue one, let's go to light blue, right above the yellow. Let's down that one. Let's make that one 40 speed and see if we could possibly cut through it going a little bit faster. And we should have the black one turn it on as one pass, because that'll cut out the square for us.
All right.
We'll try that one at 35 as well, I guess.
Okay. And
now,
purple,
let's keep that at 100 speed and try some vector marking. Now, I say we run the purple at 100 just to see what happens.
Okay. And then yellow?
Then the yellow we can run at 100 speed at 10 power to see what kind of mark that puts on the material. I like 10 power as a good mark start because it's just a good way to see like kind of where you're at. Because it's either going to live below 10 in a delicate place, or it's going to live somewhere marginally above 10.
Mm-hmm.
All right, so we're just going to zoom in here on the software just a little bit.
Yeah, did we take a picture? No.
I don't think we did. Let's just move it into the middle of the board.
Okay.
Ruben, is there room right underneath where the laser head is? Is there anything right underneath it?
It's the material.
Right, but is there anything marked on the material?
Right under it. Like.
Oh, no.
Oh, perfect. Okay, so
we'll just run it there.
we'll just run a quick perimeter just to double check our location.
That good?
That's in a clean spot. And see, there you go. And we'll hit play. And this one will take almost no time, as these lines are literally just an inch long.
Yeah.
So as you can see, it's running the black line first, which we probably should have drugged that to the end, so it cut out the outside first. So there it ran the 100 speed, 100 power.
That's fast.
We're all mesmerized. Okay, there it is now. Ruben, if you wouldn't mind just giving us those pieces as what cut through. You might want to take the big piece out first, then some of those little pieces might fall apart.
Yeah.
But try to take them out one piece at a time so we can kind of see what cut and what didn't cut. Okay, so as you see, that obviously that 35 cut pretty good. Now we'll start at the bottom and see what. Oh, you can get it all at once? All right, so that bottom definitely cut out. Second one cut out as well.
So that was at 40 speed.
You guys want it? Or?
Yeah, please hand out. Yeah. Then the big piece as well, if you could, sir.
We'll reassemble it.
And so it looks like we could get away. Oh, look at that. It looks like we can get away with going a lot faster. And this is kind of the part about running this job I like, because you can now look at the edges. Oh, thanks. And kind of see which edge you want to end up with. Because really you're looking for that beautiful brown burn, right? Which looks like we got on this last one. So as you can see, everything up into that one cut through. Which is a good way to kind of assess like where your wood's at. Now, were we fine at 35 and 100? Absolutely. Is it nice though that we can cut at 40? Yeah, you know what I would do? I would test another one at 45 and see if I can get through, and I bet I couldn't, and then I would find my dial-in spot in between there. The reason why you want to do that is you always want to use the least amount of power possible to cut through your material to minimize three things: the effective kerf, the burn on wood, and then two, accuracy. Like if you're just blasting through it with a ton of power, you're making a huge channel, it's a ton of energy, it's a ton of heat. You want to get through that channel and cut through the channel with the most efficient use of heat and power as possible.